Google DeepMind has given us a framework to think about artificial general intelligence. They have introduced 6 levels. Each of the level defines certain AI system based on the performance. And the performance threshold is based on how they are able to outperform human skilled adults, right? So the narrowest AI or the weakest AI system, which is the level 0 system, which we basically call no AI system, is nothing but a simple calculator. Then the emerging AI system is the early GPT models, the early Gemini, the early Llama models, which are slightly better than an unskilled human. They are known as emerging AI. Now, the second level, which is the competent AI system, is the newer GPT models, which is the GPT-5 model that have the or that can simulate the thinking ability. They outperform 50% of the skilled adults. Now, the expert AI, this is where things get interesting. The expert AI is defined as when you reach a performance threshold, when your AI system can outperform 90% of the skilled adults. This is where you call, expert AI, which is nothing but your specialized deep research agents. Now, level 4 is known as the virtuoso AI, where you outperform 99% of the skilled adults. And level 5 is your superhuman intelligence, your superhuman AI, where you are outperform all 100% of the humans. This is a theoretical, hypothetical, speculative future state. It's not a real state. Now, we are going to discuss the path to AGI. One of the paradigm in the path to AGI is hyperscaling. We're going to discuss whether hyperscaling is going to lead us to AGI or not. So, we have seen scaling laws in action, and the context says that, or the assumption says that LLMs are going to be the one that are going to evolve and help us emerge to AGI, artificial general intelligence. So this is kind of a hypothesis, kind of an assumption that has been made by the AI researchers till now. The AI researchers kind of think in a way that since we have scaled the architecture of a transformer, and we have seen scaling laws come into action, which is we saw a predictive increase in the performance of LLMs, which is the GPT family of today and the Geminis of today, when we increased the data, or when we scaled the data, when we scaled model parameters, and when we scaled compute. So this is what scaling laws, kind of symbolized, that if you scale all of these three parameters, you would see a predictable performance increase in your large language models, right? So now hyperscaling paradigm also states the same, that the AGI is going to emerge from continued growth of LLMs, and scaling is what is going to take us there, right? But a lot of AI researchers argue this paradigm. They argue that hyperscaling paradigm might not lead us to AGI, and especially scaling LLMs is not sufficient, is not enough, and is not the only way. It might sound theoretically that since scaling has brought us here, it might also take us forward. And it might sound nice theoretically that scaling of data, scaling of compute, and scaling of model parameters from the current state of large language models will help us achieve the cross domain intelligence and help us achieve AGI, right? But now, what is the contradiction? How do you understand the different side of the story for hyperscaling? So the first point, or the first argument, is brittle intelligence. So scaling may lead to brittle intelligence because we often see that confidence in LLMs increase more than correctness. So what are LLMs? LLMs are best at generating coherent and contextually relevant text, right? They don't really care about correctness, right? So brittle intelligence is a term that has been used to contradict this hyperscaling paradigm, which basically says that positive confidence in LLMs increases more than the truth, right? So LLMs can increasingly give wrong confident answers, right? So we don't want this kind of intelligence. This is known as brittle intelligence, right? Because LLMs only care about generating the best contextual answer. They don't really care about the truth, right? So this is the first argument against the hyperscaling paradigm. Now, the second argument that we have read that has been given by the AI researchers is the reversal curse, right? So this is also a very deeply important argument. So just imagine a relationship where we are trying to symbolize that A is B's parent, right? So model can understand this, and model can inference based on this, and model can answer correctly based on this. Now, when we query who is B's child? Basically the reverse. So the model fails to answer this unless it is explicitly trained to understand B's child, right? So the model is not able to represent these kind of relationships. It is only able to represent directional patterns. So just like humans, so humans can store bidirectional causal graphs, but LLMs can simply store tokens and asymmetric token correlations. They are not able to store these kind of bidirectional relationships, and scaling does not really fix this, right? So if we were to assume that okay, this might be the state now, we cannot understand the reversal relationships, but scaling might fix this. No, so scaling is not able to fix it. I think scaling might only amplify it, and it might not be able to completely fix it. So the third point is very, very interesting. It is an argument, from AI researchers against the hyperscaling paradigms, which is known as the cognitive scaling wall, right? So we basically want to argue that, humans have a certain way of doing things and LLMs have a certain way of doing things. And these two structures and these two paradigms of thinking, these two paradigms of reasoning, these two paradigms of planning are not at all similar, right? And scaling laws might not, build a harmonic situation where LLMs are able to reason like humans, LLMs are able to plan like human, LLMs are able to have a persistent memory like human beings, and LLMs have an ability of genuine self improvement like human beings, right? So all of the behaviors that LLMs have with respect to reasoning, with respect to planning, with respect to long term memory, with respect to temporal continuity is very, very fragile, right? And scaling the parameters, scaling the data will only give them maybe, a little more worldly view, but it will not inherently improve their structure to make them simulate or behave like humans. They will not be able to simulate a human being like thinking, a human being like reasoning, a human being like planning, a human being like memory, right? So all of these points, or all of these failure points kind of, brings a rationale to this particular argument, and it stays very strong against the hyperscaling laws or the hyperscaling paradigm. Okay, so now the fourth argument is very practical in nature. The fourth argument is basically the limitations of data, energy, and economics, right? So data and energy, we simply know we are talking about high quality data and compute. Both of them, high quality data, compute, energy, is finite, right? We don't have immense and infinite amount of user generated high quality data. We can do synthetic data also, but synthetic data has its own limitations. It might introduce more and more biases that we might not need. Now energy and compute obviously is also not finite, and training more and more, so we know it requires hundreds and hundreds of billions of dollars to, just simply train a large language model of today, right? So we don't have that much amount of energy and resources just to spend on this much marginal utility, right? So the economics do not play out. The trade-offs with respect to the performance and with respect to the resources spent does not play out really well, right? So these four strong arguments against the hyperscaling paradigm works in favor, of the critics, right? It basically signals the critique that scaling data, scaling parameter, and scaling compute might not be the only way that will help us lead to AGI.